ठीक है। अमार, आपने रिकॉर्डिंग स्टार्ट कर दी? वो मेरे पास नोटिफिकेशन नहीं आई।
Yep, it started.
हाँ ठीक है। चल, okay. So I was writing down the third law, and it just says the squares of the periods of any two planets are proportional, or I'm just going to use this directly proportional symbol, to the cubes of the semi-major axes of their respective orbits. Right, and again, to write that down mathematically, it just says the period squared is proportional to a cube, right? Where a is the semi-major axis, right, of the orbit. Okay, from here, let me just mention something that I find cool, right? I would like to go from here into the mathematics of these Kepler's laws, and then we would talk about the work done by gravity and all those other things, gravitational potential, equipotential surfaces. But let's leave that for the next lecture. Right now, I'll just talk about some things, right? One of which is what can we do with this law of gravitation? Or सबको पता है कि Earth is round, right? Hopefully, in this lecture, there are no flat earthers over here. If there are, then please excuse me. But it's very easy to see that the Earth is round, because everything attracts everything else. So the Earth has attracted itself together as far as it can. Now, I can think a bit more further and, well, say that Earth is not exactly a sphere. और वो क्यों है? It is because that Earth is not standing still or so. It is actually even rotating. And if the Earth is rotating, or in fact, if any object is rotating, then we have to consider what is known as the centrifugal effects, right? And that is just a centrifugal force is an outward force on a rotating object. Now, some of you might just say, or maybe thinking, well, that is, it's like, it's a fake force or it's a pseudo force. But this force is actually very real in a rotating reference frame. So it depends on what frame of reference we are talking about. It's just not the fundamental force, right? But it is caused by rotation of the frame of reference. And it is, well, it is, I think it's important to mention, it is not some psychological oddity that humans experience, right? But anyway, the centrifugal force tends to oppose gravity near the equator of the Earth, right? And so it turns out that the Earth should be rather elliptical, right? And so then we can deduce Sun, Moon, and Earth, and well, all the other planets, they should be nearly spheres or nearly spherical, right? Just by this law of gravitation, because the law of gravitation told us that everything attracts everything else, right? Now, well, I thought that was worth mentioning, or I would also like to add one more thing before well, before this lecture is over. uh, and well, that is something like earlier around 1676 or something. There was a certain difficulty with the moons of Jupiter, and a guy named Romer, I think, studied these moons or these satellites of the Jupiter, and he noticed that the moons sometimes seemed to be ahead or behind their schedule. Now, they were ahead when Jupiter was, well, particularly close to the Earth, and behind when it was further from the Earth. Jupiter was further from the Earth. Now, this would have been not possible to explain with the law of gravitation. In fact, this would be, well, it was a threat to this law of gravitation, right? Uh, well, that is if there were no other explanation for this. But if a law so does not work even in one place that it has to, that it's ought to, then it's just wrong. Then the law is just wrong, right? But luckily, later it was realized that the reason for this discrepancy was actually a very simple and a very elegant one, as this observation, so it gave birth to, well, another beautiful idea, and that is, well, it takes a little while to see the moons of the Jupiter. वो इसलिए uh, because of the time that it takes light to travel from Jupiter to Earth. So when Jupiter is closer to the Earth, the time would be less, and when Jupiter is further away from the Earth, the time that the light takes to reach the Earth would be more. And so this is why the moons appeared to be, uh, well, on average, a little ahead or a little behind of their schedule, depending on whether they were close or far from the Earth. So this thing showed us that light does not travel instantaneously, and so it furnished the first estimate of the speed of light as well. So I thought that was something cool that I liked to mention it. But that's it for this lecture. Next time we will look at the mathematics of all of these things. Again, like even you mentioned, okay, we will look at the mathematics of the Kepler's laws, and we will see, okay, how can we arrive at these laws mathematically as well. And we will look at the development of the dynamics, and so that is the work done by gravity, gravitational potential, and all the other stuff, right? So again, that's it for this this session.